board.
Yeah, he actually does a lot of math in his head. But okay, here moving on to our next chapter, and it feels a little bit more mathy, which I'm excited about. And we're gonna do a little bit more with like displaying data and like analyzing some like statistics, like mathy part with the actual data. Okay. So today we're going to talk about frequency distributions and their graphs. So there's a lot of ways that you can organize and describe data, and sometimes it depends if it's quantitative versus qualitative, the best way to organize or present our data. So like a pie chart, a number line, something like that. Stem and leaf plot. A lot of what we do in statistics is look at what's called its center, variability, and shape, which we'll kind of like get to that later on in lessons. But today we're just going to look at how to organize data sets and kind of group them, specifically like frequency distributions. All right, so frequency is exactly like how you would think of this word in like normal context. It's just how often or the number of times something occurs. Okay, so statistically, I like to say the number of times that an event occurs. Obviously, you hear this like in real life all the time when somebody maybe would ask you like the question like, how frequent are you experiencing da 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 da? How often does that happen? Okay, so a frequency distribution is usually modeled as a table, and it shows different intervals, or sometimes they're called classes. I'm gonna probably more refer to them as classes because that's what Alex refers to them as. So it's a table that shows classes, which are kind of like your categories, or they might be called intervals of data entries with a count, with the frequency, the number of times it occurs within each class. Entries in each class. Oh shoot, I gotta make a homework assignment for you guys.
Oh no, it's fine.
I gotta write something. All right, it won't be due till your next week, so. So here's an example of a frequency distribution. So if you went around and surveyed people and asked what type of pet they have, here's your tally marks, just keeping track. And then the frequency is the number of times people said dog, okay? Which was 12 in this case. How many people said lizard? The number of times that occurred was 1. So obviously these numbers in this frequency column should total what?
You say 7.
Well, I mean, not numerically in this example. It should total, sorry, I mean like in general,
Frequency distribution.
this should total the number of people that you like surveyed, right?
Yeah.
Sorry, that's what I was thinking.
Yeah, that's what it meant.
Yeah. So this should total.
That's a budgie.
I have no idea. What is a budgie?
I'm intrigued.
I didn't even notice that. That's hilarious. A budgie.
Like a bat thing.
Like a hamster, but like not.
Yeah.
So this should total your sample size.
What's the other thing? Not a hamster. It's not a hamster, but it's
A gerbil.
or a guinea pig.
A
Yeah.
budgie is
A chinchilla. Oh.
These over here, these would be like your classes or your intervals, your class. And then obviously these are like your frequency, the number of times people responded in each class. Okay, so that's a frequency distribution.
interesting.
So we're gonna look at an example of creating our own frequency distribution and then answer kind of like a follow-up question. I'm gonna try to more match the questions to like the Alex ones in this chapter. So I need to do that. You guys are like my little experiment group. I like this view. Okay, there were 24 participants in a recent study on personality traits. After being shown 4 images, we're just going to number the images, image 1, 2, 3, and 4. Each participant selected the one that was most appealing to them. Here are your results. Here's your data. You just jotted down what each participant answered. So it says complete a frequency distribution for this data. So we have our class, or kind of like our categories, is what image they selected. So let's list out those possible answers. It looks, obviously 1 through 4. 1, 2, 3, and 4. And then we're going to count up the frequency, or the number of times each participant stated which image they liked. So I'm just going to start with the ones. And personally, when I'm kind of like doing this with data, I kind of like to cross it off as I count. So the number of people that said 1 was 1, 2, 3, 4, 5, 6. So my frequency for image 1 would be 6, the number of times that occurred. All right, counting up how many people said 2. 1, 2, 3, 4. Ooh, lots of people said 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Leaving me with 1, 2, 3, 4, 5 people that said 4. So what you should do is you should add these up and make sure it totals your 24 participants. Just kind of like check your math, make sure you counted right. So if you quick add those all up, you do get 24, which is our total number of participants. So there's a frequency distribution. All right, follow-up questions. So those images were associated with 4 personality traits. Not every image is associated with every trait. The table below shows the traits and the images associated with them. So if you selected images 1 and 3, that was associated with that you're an optimistic person. 2 and 3, indecisive. 3, analytic. 1, 2, and 4 means impulsive. That's how they decided to associate this. How many participants selected an image that was associated with being optimistic? Well, optimistic was anyone who selected 1 and 3. So we have the number of people that said 1 was 6. Plus the number of people that said 3 was 9. So that'd be 15 participants. Okay. Makes sense, because that's the number of times it occurs. That's what frequency is. That's your basically big vocab word. All right, here's where the math comes in. After constructing a standard frequency distribution, you can include several additional features that will help you better understand the data. All right, this one's our most common, the relative frequency one. Midpoint comes up a lot. So the midpoint, similar to kind of what you do in math, is you're basically just going to average or find the middle of the lower and upper limit of each class. Okay, we'll do an example. So for now, just put average of the lower and upper limit of each class. So another way you can think of this, like a formula, if you will, is you take your upper, I usually start with lower, I'm going to put lower first. Your lower plus your upper limit in each class, and then you find halfway, so you divide it by 2, or again, you average it. So these are often used with numerical data, obviously, we can get like more numerical statistics. So you're like, oh, how would I have done that with that very first example of adding my number of cats, my number of dogs, something like that? We wouldn't be able to calculate these statistics. quantitative data only. Next one, relative frequency. So this one comes up a lot, probably the most common. And it's a ratio of how many times it occurs, so the frequency count, to the total count, to the total sample. It's often expressed as a decimal or a percentage. Okay. So a formula for this one, I'm just going to abbreviate this as RF. I often do that. My relative frequency is you take the class frequency, so the number of times each like section or each interval occurs, and you divide it by your total sample size. We'll do an example in a minute. All right, so the last common statistic calculated in frequency distributions is something called cumulative frequency. And think about what cumulative means. Like your cumulative GPA is your GPA that's representative, like from your freshman year, added on to your sophomore year, added on to your junior year, or like sometimes people say like, oh, over the last 3 days we accumulated inches of snow, like we built up that much. So cumulative frequency is just the accumulation of all the relative frequencies. Let's use purple. The accumulation, or blue, of all previous relative frequencies. Meaning, since relative frequencies are either like a ratio that's a decimal or a percent, it should like total up to 1 if we're talking about decimals, or 100% by the end. Or another way to think of it, should be equal to the sample size. All right. There's no like formula for that. I'll kind of show you how to calculate that in the next example. So sometimes frequency distributions don't always include tallies. Sometimes they do. The tally is more like them collecting data, and then the frequency is obviously like the number of times it occurs. So sometimes they might have that middle tally column, sometimes they don't. So this one says, using the frequency distribution below, find the midpoint, relative frequency, and cumulative frequency of each class. All right. So I don't know exactly what this was like measuring. The 155 to 190. I don't know. I don't have the background on that. But here's just an example of a frequency distribution. And these classes are like over an interval here. So from 155 to 190, it occurred 3 times, whatever they were measuring. I'm trying to think of something that would even make sense. That would range from 155 to 406. Dollars and like my bank account? No. Probably lower than that. Just kidding. I don't know. It doesn't matter. So let's start by doing the midpoint of each class. Okay, I'm going to kind of do that right here. So the midpoint, you find the average of the upper and lower limits of each class. So in this class, my lower limit, or the lowest possible answer they could have for to be in this category, in this interval, is 155. And my upper limit, or the highest, would be the 190. So we're just going to calculate what's halfway between those, or average them. So divide that by 2. and you get 172.5. There would be your midpoint for this class. Okay, let's just go through and calculate all the midpoints. Next class, so the same thing. You take your lower limit plus your upper limit, divided by 2. I got 208.5. These are often used in frequency graphs when we get there. Same thing here. Some nice simple math for you guys on a Friday. 244.5. Halfway there. 263 plus 298. 280.5. So this has nothing to do with the number of times this occurred. I'm just calculating halfway between each interval, each class. We'll calculate frequency stats in a second. Oops. All right, 2 more. And of course, anytime we're averaging, make sure you add them up before you divide by 2. Okay, there's all our midpoints for each class. Ooh, done. Next, we're going to calculate the relative frequency. So I'm going to down in green. So my relative frequency is a ratio of my number of times it occurs, aka my frequency, to the total number of my sample size. Now, they don't tell me how many people were sampled here, but how can I figure that out? Yeah, add up the frequencies. If this occurred 3 times, 2 times, 5 times, total that up, you get 30. Okay, so these are the ones that are often written as decimals or percents, and Alex more commonly uses decimals, so we're going to do decimals. So for my first class here, this occurred 3 times out of my total 30. So that's just 1/10, 0.1. 0.1 would be my relative frequency. Okay, next class, 2 out of 30 is, I rounded this one. I think Alex has you round to 2 decimal places, so we'll just do the same. It's 0.07. Next class occurred 5 times out of 30. Here's that ratio. It's about 0.17. Next class is 6 out of 30. 2/10. 7 out of 30. About 0.23. Or again, these could be like percentages, like 23%, 20%, 7%, etc. All right. Next class, 4 out of 30. 0.13. Last one, 3 out of 30, 1/10. So there's how you calculate relative frequency. And again, relative frequency is another way we can kind of like model and put these into visuals of displaying like our data. All right. Cumulative frequency, lastly, is the accumulation of all the previous relative frequencies. All right, so after class 1, we only have 3 total frequencies, so that would be 3. Do I add up? Relative frequencies. Let's do this. Let's do 0.1. 0.1. Okay, so then to calculate my next cumulative frequency, I would do 0.1 plus that. How do I want to show my work here? I do the 0.1 plus the next one. So we get there. All right, and then I build off that. So then I take that 0.17 plus my next 0.17, and we get about 0.34. All right, and then we just keep building off of that. There's that cumulative. 0.34 plus 0.2, 0.54. Next one, 0.54 plus 0.23 equals about 0.77. And if we do this right, it should total up to 1. 0.77 plus 0.13. And I'm putting approximately because we rounded a lot of these, but here's my 0.9. 0.9 plus 0.1. There's my 1. Okay, and if we would have done this as percentages, it should have totaled 100%. Another way you can calculate a cumulative frequency, which I did in my notes, is you can take like this frequency plus this one plus and accumulate that way, and it should obviously equal like your total and your sample size. But it's more commonly an accumulation of your relative frequencies. Okay, see, this is more mathy. So we'll kind of get into like what we can use this data for. Right now, we're kind of just doing the math. All right, I'll let you guys try this one. So there are 15 students in a certain painting class. Their ages are shown below. Complete the grouped relative frequency distribution for the data. Okay, so when they say grouped relative, they just mean like it's from 18 to 22. How many people fall in that category, not just like 18, 19, 20. That's what they mean by grouped. So you're going to have to calculate, obviously, the frequency first. So you can put that right here if you want to. Frequency first, and then calculate the relative frequency. And let's do decimal round to the nearest hundredth, not as a percentage. Okay. I'll give you a couple minutes. How you doing?
I'm done. And these two, I need to because. Yeah. Got it. Okay. I'm going to have you write these down.
And Max graded these, but he started writing them down and ran out of time.
Okay.
So this is the 6th one book, and then we need to write them. How did they tell these look?
They're also pretty good. I don't think they're all here though.
Oh shoot, Dalton turned his in today. Sorry, it was right here. So, do you grade like 5 1 is 5, 5 2 is 5?
Yeah.
So he could get max of 4 on each. So max of 12. Okay. Is how I do it. Yep. Okay. And then the geometry.
Should I just put reading for these two? They're both like,
Yeah.
they're smaller.
This one's Oh, he told me. He told me he was going to do that, and I gave it back to him. He must have just tried to sneak it in again.
There's a light right there that's crossed off too.
Interesting. Interesting. Okay, here's what you should add for your frequencies. 18 to 22, there was only one. This 22-year-old. 23 to 27, I found 8 of them. Ooh, 23 to 27. What a great age. Oops. I thought that said 23. Okay, there's those 8. 28 to 32, I found 4. And then 33 to 37, there's just these 2. Okay, so there's a frequency. So for the relative frequency, you should have done 1 divided by 15. Since there's 15 students in this painting class. So 0.07 would be your final answer for that. Written as a decimal round to the nearest hundredth. 8 out of 15, a little over half, 0.53. 4 out of 15, 0.27. 2 out of 15, 0.13 is what I got for those. So if we do represent the relative frequencies like as a percentage, you could say like 53% of your participants were ages 23 to 27. 53% of this age group, or of your population, was this age group. Okay, here's how sometimes frequencies can be modeled. I guess like displayed would be a good word. Is by a histogram. And you're like, what the heck? That looks like a bar graph. And you're right, but bar graphs are for categorical data. So the numerical data of bar graphs are called histograms. Do you know that? Yes, no, maybe. Okay. Graphs are really important. I swear, when I took the science ACT, it was like all interpreting graphs. So this is good. So a frequency histogram, it uses bars to represent the frequency distribution of a data set. So it's essentially a bar graph for quantitative, which means numerical, quantitative data. One characteristics of histograms is that the bars always touch. There should be no graphs. So when you go to like make some of these, the bars must touch. It's just kind of a way that histograms are displayed. Bars must touch, no gaps. So here's an example of a frequency histogram. So you have your class that's usually represented on the x-axis. So here what I was looking at was the test scores, and then you have your frequency on the y-axis. Your frequency is usually on the y-axis. So it's showing me how many test scores were in each range, in each interval, in each class. Okay, so it looks like obviously the majority of our test scores were right within that 80 to 90 range. 16 of them. Okay, let's draw one. Here are the hottest record temperatures in degrees Fahrenheit for each of 18 cities throughout North America. Holy smokes. Complete the grouped frequency distribution for the data. Okay, so they're grouping how often was it 94.5 to 100.5 degrees, and it kind of goes up from there. So first let's just calculate the frequency. All right, you guys counted up. How many of those were in that first class? 4. Yep, 4. Okay, and then like I said, I kind of like to cross them off as I go. What about the next class? I counted 4.
What? Oh.
1, 2, 3, 4. 106 would fall in that category. Cross them off as you go. That helps. All right, 106.5 to 112. That would be 1, 2, 3, 4. Leaving me with 6 in that last class. If you're ever not sure, add them all together. That should equal the 18 cities. 1, 2, 3, 4, 5, 6. Okay, so we're going to construct a histogram, which is really just a bar graph of numerical data of my frequency here. So from 95 to 100.5, my frequency was 4. So you're going to find 4. You can shade it in if you want to, you don't have to. There's my frequency for that first interval. My next one is also 4. This is going to be a pretty boring graph. From here to here, also 4. 106 to 112, 4. 112 to that 118.5, 6. Mine looks like Christmas. All right, so there's an example of a histogram. And we will do like an actual like activity where you're gonna like survey some people, collect some data, and I'll show you how to like make these on either Excel or Google Sheets or maybe a website. I haven't quite decided which one's easiest. It's gonna be fun. I think it'd be fun if you guys surveyed some like middle schoolers. Wouldn't that be fun? You need to go downstairs and survey a middle school or something. Middle school study hall. That'd be so cute. I love going downstairs. I'm like, they're so little. Or when we go in the gym and they're sitting up, so small. I never see them over here. They're so cute. Okay, let's maybe talk about one last thing here.
It's really annoying though.
Yeah, I can never teach them.
Yeah.
So we have something called frequency polygon. And it's basically if you were to kind of create like a line graph through your frequencies or like kind of almost through the histogram. And it's called a polygon graph because it has many sides. So the way I think of it is a line graph. That emphasizes the continuous change in frequencies. Again, it's called a polygon. Looks like this, has many sides. Okay, so here's an example. You can see we're still like plotting our frequencies, but instead of creating a histogram with like bars, we're using a line plot, and it's more shaped like, or sorry, not a line plot, a line graph, and it's more shaped kind of like a polygon. So with the histogram, if you kind of wanted to shade this in, it could kind of look something like this, like within this interval, maybe that was like the midpoint. Might look something like that. I don't know, I'm kind of just guessing what it could look like. So a frequency polygon instead plots them and just connects a line. Again, you can kind of see like the changes in frequency. That's what that emphasizes. Is saying. Okay, so let's just try one example and then we'll call it a day. Ms. Hendricks gave her students a stats test this week. This is not true data because I had to do more than just you guys. Here are the scores for each of the 16 students. All right, so let's complete first the frequency distribution. So from my 71.5 to 75.5, there were 7. I counted. 1, 2, 3, 4, 5, 6, 7. 75.5 to 79.5. 1. 79.5 to 83.5. 1, 2. 83.5 to 87. Man, this must have been a hard test. Oh, scores. 83.5. Oh, sorry, 80. Yeah, to 87. 1. And lastly, the 87.5 to 91. 1, 2. My 5. Okay, so this says draw the frequency polygon for the data and label each class with its midpoint. Okay, so we're gonna have to calculate the midpoint of each class. So remember, you just average these, the lower and the upper. So let's just put that over here. All right, so the average there, and you could probably actually do this without doing the math, would be 73.5 for that first class, 77.5 for the second, 81.5 for the third class, 85.5, and then 89.5. So that's basically how they want us to plot this on like the x-axis is by the midpoint. Okay, those dots, don't worry about those dots. That's just a screenshot of something else. So, okay, so our first one, 73.5, so the midpoint of that class. I'm just gonna place it here. The frequency was 7. So you're just gonna put a dot. We're not making bars. We're making a frequency polygon. 7. 77.5. So I'm kind of just over here. Kind of try to evenly space it. 77.5. There was only one score. 81.5. I had 2. 85.5. So again, I'm just kind of trying to evenly space them. I didn't do a great job. 85.5 midpoint class. I only had 1. I'm gonna put the numbers above it. And my last one was 5. Okay, so to create this frequency polygon, you would take a straight edge and you would just connect all your dots in a linear fashion. So like that. And then you typically see these like go down on each side too. So there's a frequency polygon. Oh yeah, it does say label each class. Oh yeah, read that. It's midpoint. Polygon says many sides. Specifically 1, 2, 3, 4, 5, 6, 7 sides. Heptagon. All right, we'll stop there for the notes.
I saved you guys
Why are
a minute
you-
or two.
Why
Don't worry, we're just so